am Indrajyoti Gaine. Presently, I am a PhD student at Department of Mathematics and Statistics, IIT Kanpur. I am a PMRF fellow right now, and before that, I was a CHR fellow. I have cleared my CHR net with 108 rank. So from the last class, we have discussed about the three-dimensional geometry, and in the the beginning class of the introduction to the three-dimensional geometry, we have discussed about the coordinate of a for particular point in 3D space. And by reference, we have considered the corner of our room to understand the location of any object hanging from the wall or kept inside the room or somewhere in the room. How we can locate that particular point depending upon the any corner of our room. Also, after that, we have discussed about the coordinates of the octanes of the 3D surface, 3D space. That is how we can divide this 3D space in 8 octane. And depending upon the octane, we can locate that particular point and we can do our further study for better understanding. And depending upon the sign of the coefficient of the numbers, we can clearly understand that that point lies in which octane. After that, we have find the how we can locate a particular point. If the point coordinate of the point is given, then how we can achieve that point, or if the only the point is given, then how we can find its coordinate, right? And we have shown that the whichever path we choose, we will ultimately achieve that point, and coordinate values will not get any change. After that, we can also discuss about the importance of the signs of this point, because depending upon the sign, we can decide that this point lies in which of. And after that, we have discussed about some coordinate planes and coordinate axis. And so today we will start from the um, important concept of distance between 2 points in 3D surface. So whenever we discuss about the in a plane, so first of all, it is important or not. Question is important or not, because whenever we are lying in the same surface, we may ask that how far we are from each other. Like your friend can ask that I am 1 kilometer away from you. Just come by right away. Okay, this is the importance of the distance between two points. Now, you and your friend, whenever you discuss about the distance between you and your friend, then you are moving on the 2D surface. Why 2D surface? Because you can't move in a along the z axis. You can only walk by the plane surface. That is our xy plane, or you can consider as any plane. That is only plane, but it is not a surface. But whenever I ask that what is the distance between your ceiling fan and a bulb hanging from the ceiling, it may depend, because sometimes it may happen that we need to put something between these things. So we need the measure. Or you can say that whenever your curtain is hanging from the window, and you may ask someone that what is the distance between this point and this point. Accordingly, they can buy a curtain. So this thing is important. So that's why we need to understand that how we can find the distance between 2 points in the 3D surface or 3D geometry. So for that, let us draw the axis first. So whichever we have discussed here, we consider this one as plus plus plus. So according to the coordinate, we can draw like this. Just think about it is a 3D drawing. This is our origin. This is our x. This is our y, and this is our z. Now we have 2 points here. Suppose one point is this red one, denoted by P, and another point is somewhere like here, Q. Now these 2 points have some coordinate. So how we can get the coordinate? The coordinate can be obtained like this, like how much distance we need to cover along x, then how much along y, and after that how much along z. Accordingly, we can find the coordinate of the q axis, q point. Similarly, for p point, we can work like this, after that like this, and after that like this. Okay. So along this we can find the uh, coordinate of the point P and Q. Now what we need to find? We need to find the distance between these 2 points. Distance means this length we need to find. Okay. How we can find that? So first draw a rectangular parallelepiped with this point. How? So join this one first. This, this, so this, this one, and after that, this one is it's it will belong like this should be the corners. So these 3D drawings are little bit difficult. So first you need to understand and how can mainly the thing is like we have to put this like this. If this is the parallelepiped, so I'm saying the first basic idea, then you can draw the things. This is our parallelepiped. Okay. Now I want to put these 2 points like this. That this red point P should be at here, and Q point should be there. We want to place this parallelepiped in the 3D plane like this in such a way that this should happen. So better understanding, we can erase this one and we will go with that one so that you can understand it properly. Otherwise, it can be miss basic. Yeah. Okay. And let's draw the coordinates by like this. This is our z axis. This is our x axis, and this one is our y axis. Okay. This is z, that is y, and this is what is x. And the green colored box is representing the parallelepiped in the 3D surface. Just try to visualize this in the 3D surface so that it can be more clear. Otherwise, it will be much difficult to explain it because if you are thinking in the 2D surface and you are doing the calculation, then it will be not that much clear to you. So think about like you have put a matchbox in a 3D surface. Okay, think like that. Okay. Now, what we need to find? We need to find the P and Q, the distance between P and Q, like this one. So this is nothing but a diagonal of the parallelepiped. Now, how we can achieve this diagonal? So let's draw it here for better understanding. Again, this Gaine, Okay, this is the point Q. This is the point P, and we have to find this distance, right? From here, it is clear that we have to find this distance, P and Q. Okay. Now, to find P and Q, we can how we can achieve this point. So from Q, if I start walking along this, like first along this one, then after achieving here, we can move along this one, then along this one. This is one way, or we can have many ways to achieve from Q to P. Here now, if I take a projection of this yellow line on this surface, this green one, on this surface, then how it look like? It will look like something like this. Just I am taking the projection of this QP line on the basement of the triangular figure. Okay, then it will look like this one. Now, what is projection? Projection, or your understanding will be better to feel like that. Projection is if I put a light. Suppose PQ is a rod. PQ is a rod put in the been put in the diagonal in the light box. Now I have a torch and I have turned on it from the top of the box. Now I am getting a shadow of this euro rod on the base. That is a projection. Because euro shadow, that is black shadow we are getting for that euro rod. That is the projection. Black shadow. Now this is nothing but a diagonal of the basement. So to get this PQ length, we can only use this thing because this is making a 90-degree angle. This yellow line and this green line, this makes a 90-degree angle, and we obtain a triangle from it, right? We obtain a triangle from here. Now, from the coordinate of P, we know the distance. What is the distance? This is Z distance, right? So Z distance means this is the extra height from Q. That is the extra point, extra height that achieved by P, which is not achieved by Q, right? So this, if I name it, like P has coordinate x1, y1, z1, and Q has coordinate x2, y2, z2, and h2 and other two. Yeah, understand. X2, y2, z2. Then this yellow line is nothing but the length representing this length is z1 minus z2. Why z1 minus z2? Because whenever if you look at here, so at first you can go Q, then P is above Q. From the geometry you can see that P is above. So we need to cover extra height or extra distance along Z to go to P, right? Or we can clearly see from here that whenever we are moving like this, so we are moving some distance from along x-axis, extra distance along y-axis, and extra distance along z-axis, right? So together this we can say that we need to cover extra z1 minus z2 distance. Okay, so this P, and if I say this is point EM, then we obtain this PM. To get PQ, we can, for which the right angle triangle, you can say PQ square equals to PM square plus NQ square. Right? Now, what is PM or in that? PM is no, that is 0 minus Z whole square. Now, we need to find what is NQ square. Okay? And if I obtain this NQ square, then PQ square we obtain, and square root, positive square root of PQ will give us the actual length of this line PQ. Now we need to find MQ. To find MQ, we will work with only the base. Now I have drawn a plane in 3D. The naturally plane looks like this rectangle type of thing. But I have drawn it in a 3D surface, so it is looking like this. Okay, don't get confused by this only. This is not a 2D surface, it is 3D. You can say like this one is our z axis, this is our y axis, and this is our x axis. Sorry, this is your y axis, this is our x axis. Now one can say that why this y is missing here, because I have put the plate on the space, so that is floating. That's why you can't see the data y axis like that. For better understanding, I have drawn like that. You can also rub it here for better understanding. It looking like it is floating in a space. Now I need to find this MQ. Need to find this MQ. Or it is drawing your like drawing your MQ. This is our M. This is our Q. M. M. This is our Q. Now to obtain the MQ, we can do what? So it is nothing but the rectangle like this. So if I just see from the top, then it will be nothing but this this green one, right? So this yellow line should be like this. This one is M, and this one is Q. Now this is again a right angle triangle. So it is enough to square this one with square this one and them and take the square. So clearly we can say if I name it like P not P, it's like I name it like MN. So MQ square, this is nothing but MN square plus NQ square, right? Because of this is right angle square. Now from here, from this figure, we know that what is this the length will. What is this length? This length is how much distance we need to cover extra along x axis to go to P. So this distance will nothing but x1 minus x2. This here also this will be x1 minus x2. Similarly, how much distance we need to cover extra along y axis will be given by this y1 minus y2. Here also this is y1 minus y2. So using this formula, we can say that mq square this is equals to x1 minus x2 whole square plus y1 minus y2 whole square. Okay. Now we obtain mq square. So from this equation, from 1 we get q square equals to z1 minus z2 whole square plus this mq square means x1 minus x2 whole square plus y1 minus y2 whole square. Right? Now, for getting the actual length of this peak, we need to go with the positive square. Why not negative square root? Because we are working with a length, and length can't be negative. You can't say that the length of the distance from you and your friend is in the negative quantity, like minus 10 meter or something like that. You can't say. The length should be always positive. That's why their PQ will be positive square root of x1 minus x2 square, y1 minus y2 square Z1 minus Z2 square. Okay, so this is the length of the PQ obtained from here, and this PQ representing the distance between these 2 points P and Q. Now, I have derived all the methodology behind this finding the distance between P and Q. Now, whenever you are going with some competitive exam or your board level exam, you don't need to do all these calculations to get your proper answer. Yeah, if you forget this concept, then or if you forget the formula, then only you can regenerate this idea and you can find the formula for PQ, length of PQ. But in general, you just do on the formula in the formula here. That is length of PQ equals to the square root of it, what their distances, well, I mean the pairwise distances, their square sum. Like PQ equals if we can compare it with the case with the real plane, or you can say the R2, you can say with the plane. So whenever we are finding between 2 points, we have used a formula like square root of x minus x whole square plus y minus y whole square. Now here, as it is a three geometric, we have additionally added the extra term that is Z1 minus Z2 whole square. Nothing else. Now, next question comes that I have discussed about the point when the point Q is there. Now, if I place this Q as origin, like here x2, y2, z2 is this is a case. Let's make Q is origin. That is 0, comma 0, comma 0. Okay. Then this PQ becomes in place of x2, y2, z2, put 0, 0, 0. So we get x1 squared, y1 squared, z1. Okay. So whenever you are asked to find a distance of a point from the origin, you can just do the square root of this. You can just do the square of the each coordinate and take the square. That will give you the distance from the origin. Because the x2, y2, z2 was 0, so you can use the formula directly and you can get this thing. The case. Now going to example. We must see the first question is application of this distance formula. Find the distance between the points 1 minus 3, 4 at q is minus 4, 1, comma 2. Okay. So the coordinate of the two points are given in 3D data for the table. Now we need to find the distance between these 2 points. So one thing you can do that you can first put this point in the for our 3D surface, 3D space, and you can put this accordingly at the side. Depending on the sign, you can put it on the proper octane. So after that, you can find use the formula of this thing, or you can use the whole concepts behind this, or else all these things can be done by you, or else the best way is just use the formula. Okay? You don't need to do a lot of work. Just use a formula. So here x1, y1, z1 is given. X1, y1, z1 is given. Here x2, y2, z2 are given. Now we need to find a distance. The distance between these 2 points. Just 2 points A. 1 minus 4 whole square plus minus 3 minus 1 whole square plus 4 minus 2 whole square. Just I have put in the point, the coordinate of the point in the above derived formula here. So I obtained this one. Now just do the calculation properly. 1 plus 4 minus 3 comma minus 1, that is minus 4, and this one is 2. So this one nothing but 5. 4 plus 1 is nothing but 5. So ultimately we get 25 plus 16 plus 4, which gives square root of 45, which further gives 3 root 5 units. Now, why I have written units? Because you must use this unit term if the distance is not given by any measurement. Otherwise, it will be in centimeter, meter, and anything else. But whenever any measurement is not given, please write units. Next, go to next example. The question is, so that the points minus 2 pi q thing and r minus 1 collinear. These are collinear. Now, what is the meaning of collinear? Collinear means it is lying on a same line. Now, in a 3D surface, you can think of like a line. It will be looking like this. It is suppose our 3 axes, 3 coordinates, you can say. Now, any line can be looking like this or like this. This may happen like anything. Now, whatever the question is given, that these 3 points, like P, Q, R, like if I have a line like this, okay. Now, if the P point is here, Q point is here, then R point must be here. Now, how we can think of that these 3 points are collinear or not? One way is that we have this is about straight line. So one way is that you can find a equation of the straight line passing through this P and Q, and we can check that the R point is lying on that straight line or not. For that, you can use the equation. How we can find the equation of the straight line passing through 2 points. Right now, this is one way that we can find the equation of the straight line passing through 2 points, and checking the third one is satisfying the equation or not. This is one way. What is another way? Another way is that if we can find the distance between these all points, like PQ, QR, and PR. So suppose this is our P, this is our Q, this is our R. Now I can find a distance of PQ. I can find the distance between QR, and also I can find the distance between PR. Now, if and only if these 3 points are collinear, then only it may happen that the PQ plus QR will be equal to PR. Okay. So this equality will only hold if these 3 points are polar. So how we can use the distance thing? If you don't know about straight line, we can only use the fact of distance, or you can use it conveniently, because whenever it may happen that the equation of the straight line, finding the equation of the straight line is little difficult. After that, you need to check that the straight line equation satisfying by the point or not. So one can approach like this, that they can find the distance of P and Q, distance of Q and R, and check that the distance of P and R is sum of PQ and QR or not. Okay. So first of all, draw find the distance of PQ. Get the formula directly. So PQ is minus 2 minus 1 whole square, C minus 2 whole square, I minus 3 whole square. So this will give us 9, this will give us 1, and this will give us 4. So in together, it will give us 14. It was 14. Next, QR. QR is 1 minus 7 whole square plus 2 minus 0 whole square. A plus 1 whole square. Why plus 1? Because minus minus plus. So ultimately we get minus 6 square, 2 square, 4 square, 36, 1. So ultimately it gives us square root of 56, which is in general we can say to square root of 40. Okay. Now we are left with P and R. What is P and R? Minus 2 minus 7 square. That's 3 minus 0 whole square. 5 plus 1 whole square, which implies 9 square minus 9 square, 3 square, 6 square, 81 plus 9 plus 36. If I add those all these, you have to only obtain square root of 126, which is nothing but 3 square root of 40. Now we have obtained all the pairwise distance between the given points. So PQ, QR, and PR we obtain. Now clearly from C you can see that if I add the length PQ and QR, PQ and QR, this is give us PR. Okay. Now by this condition, we clearly can say that these 3 points are polynomial. Okay. Now next question is, are the points 3, 6, 9, B is 20, 10, 20, 30, and C is 25 minus 41, 5. At the point, these are the vertices of a right angle triangle. Is it or not? So if these 3 points are vertices of a right angle triangle, then one can clearly say that sum of the length of the two, square of the sum of the length of two, then it will be equals to square of the third one. Say that is, if I draw it geometrically, it will look like this. Suppose I have ABC like this. A, B, C. Suppose I don't know that which coordinate will do which one. Just suppose I am saying that these three happens. A, B, and C are located like. The question is that is it a right angle triangle or not? Okay. Now it to be a right angle triangle, then it to be like AB square, satisfy this condition. AB square plus AC square. This is should be equals to BC square. For that, we need to find AB, we need to find AC, and we need to find BC. And after that, we can check that this condition satisfying on. Mainly, now the next question comes that how we know that which one square and which one square should I add and we compare with which one square. So in general, we usually do that. We pick the smallest two lengths, like there are three lengths given, AB, BC, AC. Now, if the length of AB and BC are smaller, then we take the square roots of them, squares of them, and take the sum and compare with the square of the largest. If these three are equal, these two become equal, then it is a right angle triangle, otherwise it is okay. So here also we are finding AB, BC, and AC. Simple thing we can use we can directly use the formula. AB is nothing but I am not doing the every step by step calculation, but yeah, 10 minus 3 is equal to 7 square, 20 minus 6 that is equal to 14 square, and 30 minus 9 that is equal to 21 square. So this together will give us 49 plus 196 plus or 41. I will keep the square root because I need to square again, so I will not remove the square root here. So better don't need to do lot of calculation because we need. How else we can find AB square here? Really better. AB square is this implies 686 because I have removed the square root. So I just need to add the three quantities and we get the result. Similarly, we can find BC square. BC square will give us 25 minus 10. This is 15 square. We need to write all the steps. 25 minus 10 is equals to 15 square plus minus 41 minus 20. So ultimately, it will give us like this one. So that's why you should not skip any line because this thing may get confused. Okay, plus 5 minus 30%. Okay, then 15 square. This plus it will become plus, so it will give us 61 square. Okay, and this will give us 25 square. So ultimately, this will give us 225. This will give us 3721, and this will give us 620. Right. If I add all those things, we will get 4571. Okay. These two things we have obtained. Now, what about AC square? AC square is or AC is not in between SCA, similar things. because I whatever I have written AC or CA, depending upon that, the direction of the line get changed. I'm not bothered about this thing. I'm working with length only. That's why I'm not doing all the things. But if you go to as a vector sense, if in physics you will learn about vectors. So whenever we go with the vector sign, you need to be very much aware of this AC or C. Okay. So if you are writing AC or you are writing C, these two things are not equal in term of vector. Yeah, their length are same. Whenever you go with the length of the these two vector, they will be same, but the direction of the vectors are completely opposite. So take care of these things. Here we don't need to bother about that. So what is CA? So for that we can do like C minus 25 whole square plus 6 plus 41 whole square plus 9 minus 5 whole square. So this implies 484. This one is 4, this one 47. 47 square means 2409 plus this is equal to 4. 4 square is equal to 16. So if I add all those things, we will obtain 7. Now clearly you can see these two are small. Green got smaller and this red one is large. And now the next step is this satisfying this condition or not? Now clearly you can see that the sum of these two smaller one like 686 plus 2709, it can't be equal to 4571. This means AB square, CS square, these two are not equal to basis. Okay, so this condition is not holding in our case. So we can say this triangle is not right. So this point are not vertices of a rectangle. Triangle. Okay. Now let's go to next question. It is a little bit better question than these easy questions. Next question is the centroid of a triangle ABC is 1, 1, 1. If the coordinates of A and B are 7, then minus 1, 7, minus 6, minus 6, then find the coordinates of the points. Okay. So the question is that they have given the coordinate of the centroid of the triangle ABC, and they have given with two coordinates of the triangle. they have asked that what is the third point, or you can say what is the third coordinate of the point C. Okay, so let us draw the triangle first. So this is our triangle. Okay, so all these things are in 3D. Okay, don't think like this is I have drawn in 2D space. It can be placed like anyhow. This can be placed anyhow. Like if you have a triangle or something, and you have hanged it from the ceiling of your room, it may hang in your room anyhow. It will hang, right? It may happen like it is the top is up and the bottom is like lying there, or it may happen like anyhow. Anyhow, now this is our ABC. A, B, C. Suppose the coordinate of the point C is X, Y, Z. Okay, and A and B as coordinate like T minus 5 7 minus 1 7 minus 6. Okay, now what is the given extra condition? That 1 1 1. 1 1 1 is centroid of the triangle. That is what? Yeah. That is the coordinate of the point is 1. Now what is centroid? Centroid is that if we add all the coordinates and divide by 3, whatever we get, that is the centroid of the triangle. Like if the coordinate of the side of a triangle is like this, y1, z1, x2, y2, z2, and x3, y3, z3, then the coordinate of the centroid will be x1 plus x2 plus x3 divided by 3, y1 plus y2 plus y3 divided by 3, z1 plus z2 plus z3 divided by 3. This thing. This will be the coordinate of the centroid of the triangle. So in our case, we know about two particular points and one is unknown. So just considering that XYZ, we can say that the centroid have the coordinate like x plus 3 minus 1 divided by 3, which is equals to 1, y plus 7 minus 5 divided by 3, which is equals to again 1, and z plus 7 minus 3 divided by 3 is equals to 1. Now from here, what we can write? X equals to 3 minus 2 is equals to 1. From here, what we can say? Y equals to 3, which further implies y equals to 1. Have this play because 3 minus 1 is 2, and I am multiplying this 3 to here. So ultimately, we are getting this thing. Okay. Similarly, here, z minus 7 minus 3, 1 by 3. I am doing it step by step. Yeah. Z minus 1 equals to 3. So z equals to 3 plus 1 equals to 4. Okay. So thus we have obtained. Okay, I have done something mistake. Okay, so this one is plus. So z plus 1 equals to 3, which implies z equals to 3 minus 1 equals to 2. So we have obtained the coordinate of the point 6. Hence, of the another that will be 1, comma 1, comma 2. Okay. So this is the coordinate of the point C here. Will give us 1, comma 1, comma. Okay. And you can also check that this thing is given by this or not, like 1 plus 3 minus 1. This will give us 3 again, 3 by 3, 1. So thus we can get that this coordinate of the center we are satisfied by this point also. And we have obtained this three coordinates. I can say the rest of the coordinate of this given triangle. One is done. Now go with the next question and to the last question of the lecture. Okay. The question of the set of points which are equidistant from the points 1, 2, 3 and 3 cube minus from the points 1, 2, 3 and 3 cube minus. Now, if you have attended my classes in that Punish section, we have done this kind of concept that we are finding location of all those points or which are equidistant from particular points, particular lines. Like now, here also we need to use the same concept. So, suppose we have a point x, y, z. This x, y, z is can be variable. X, y, z is a point. This can vary. Obviously, we don't know the exact value of this. Now, distance of this x, y, z from this one and this one are same. So I just use this concept here. So according to the question we have x minus 1 whole square, y minus 3 whole square, z minus 3 whole square is equals to x minus 3 whole square, y minus 2 whole square, z plus 1. This implies x square minus 2x plus 1 plus y square minus 4y. That's z square minus 6z plus 9 is equals to x square minus 6x plus 9 plus y square minus 4y plus 4 plus x square plus 2z plus 1. Now this 1 get cancelled, 4 get cancelled, 9 gets cancelled. X square, y square, z square, x square, y square, z square got cancelled. Only left with what? So we get 4x because 6x come to this side is plus 6x minus 2x. Ultimately, you obtain 4x. So it's like this, like what's it? 6x minus 2x plus 4y minus 4y minus minus 2z plus 2z is equals to 0. Okay, and this thing is nothing but the given by 4x plus 0 minus 8z equal to 0 is equals to x equals to 0. So this is the equation of the set of all points which are equidistant from the points 1, 2, 3 and C2 minus 1. If I have to check that I have given any, I have done the calculation mistake or not. If I have not done any calculation mistake, then see the question. Otherwise, you can also check that it is right or wrong. But the idea is this: you need to follow this idea, and you can get this location of all those points which are distance from the point 1, 2, 3 and C2 minus 1. So let's stop at this point. In the next class, we will try to discuss few more examples regarding this 3D geometry, and we will end our this chapter by next day.